quite clearly in a mood. So we did this back in chapter 1 where we described our end behavior. And what that is, as we would say, as x approaches negative infinity, so as x gets real small, what happens to our y's? As x gets real small, what happens to the y? Goes up. So we say that y approaches positive infinity. It goes up. As x approaches positive infinity, so as x gets real big, what happens to our y's? They go down. So the way we say that is that y approaches negative infinity. So again, this is fancy schmancy math talk for left arrow down. And this one or left arrow up, excuse me, sorry. And right arrow down. That's what these two things mean. We're going to be using these again today, so I promise we're going to go through all the possible options and what we mean and what we intend and all that stuff and what all these things mean. But just reminding us that we have done it before. It's just been a minute. Okay? So that's all we're doing on those. We're just describing the arrows. That is the end of that bell work. What we're going to do is we're going to start looking at other powers, and we're going to be able to graph power functions. So this chapter is going to be all about power functions, namely meaning when our exponent is bigger than 2. A lot of times we are going to deal with 2's as well, but they're always going to have an exponent. So this is the technical definition from your book. You do not have to write all those words. We have done all of these things before. Things that are probably particularly helpful are kind of our generic form. And that is kind of the generic form of a monomial is the new word for that. So we are going to be dealing with monomials to begin with. What a monomial is, you know how we have like the x squared plus 3x plus 12? That is a trinomial. It has 3 pieces. If I have 3x plus 7, that is a binomial. It has 2 pieces. So a monomial has one of the pieces that we use to build an equation. It has one term. And it can have numbers or letters or both as long as they're all multiplied together. So a monomial is a set of things multiplied together. We usually use a series of monomials to build binomials, trinomials, or polynomials, which is what our chapter is going to be about. Polynomials. Yes, dear?
Can you repeat the definition again?
So a monomial is a number, letter, or combination thereof multiplied together. Absolutely fine. Why are my boots clicking? But my boots are clicking. And what we're going to start with is we're going to start with figuring out our degree and our leading coefficient. Again, not new, but it's been several weeks since we've done it. Probably a couple months. Does anyone remember what the degree is? So if we look at this first one. Our degree is actually going to be the n in our little kind of generic form up here. It's always our exponent. So the degree of this term is actually 2. So our degree is 2. the leading coefficient, and that's n is the degree. Our leading coefficient is the number in front. So in this case, it's 3, and that was the wrong color. 3. We're going to be using these to help us write out our end behavior, so it is important that we can find our degree and our leading coefficient. So on the one with the y over here, what is our degree? 3. It's the exponent. What is our leading coefficient? Negative 1/4. Bless you. It's the number in front, and that does include the sign. So the degree is the power, and the leading coefficient is the number in front. Questions on those pieces? It's not super complicated. We're just identifying at this point. Because the reason we care is our degree and our leading coefficient actually tell us everything we need to know about how the arrows happen on our function. So we're going to write a few things down. So we're going to start with our degree. If our degree is even, so looking at that exponent, I normally say it's ax to the n. So this is looking at our even exponents. So n is 2 or 4 or 6, continuing on. Even numbers, right? If our a is positive, the way I do this is I think about a parabola. We're very comfortable with them. We've worked with them a bunch. So if the number in front of my x squared is positive, we have a smiley face, right? And if we have a negative in front of my x squared, we get a frowny face, right? Even degree functions are going to have these arrows every time. So to think about our positive leading coefficient, our smiley face parabola, what that tells me is as x goes to negative infinity, so my left arrow, my y approaches positive infinity. My left arrow is going to go up. And my right arrow, as x approaches positive infinity, my y approaches positive infinity. My right arrow goes up as well. So if we have an even degree and a positive leading coefficient, so a positive number out in front, it's going to be a smiley face parabola. Or at least it's going to have the same arrows as a smiley face parabola. It may have wiggles and squiggles in between, but it's going to have those same arrows. So then we're going to write it out for if it was a negative leading coefficient. So if we have a negative leading coefficient, that's when we're going to think about a frowny face parabola. Because we're still in those even degrees. As x approaches negative infinity, y approaches negative infinity. Because my left arrow is going to go down. And then my right arrow is very much the same thing. As x approaches positive infinity, my y approaches negative infinity, because that one is also pointing down. So it's describing the arrows. As x gets real, real big, my y's get real, real small. And as x gets real, 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 real negative, my y gets real, 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 real small. So when you have an even degreed function, I use a parabola because we're more comfortable with them than we are with like a fourth or a sixth or an eighth or a 10th root or a 10th power. So then we have a similar trick thinking about our odd degreed functions. So again, looking at that degree, that's the exponent. So the n would be odd numbers like 1 or 3 or 5, etc. We're not going to have any negative exponents. That's not what we're going on here. So it's going to be 1 or bigger. And you guys have worked with power of 1 functions for years and years and years and years. Because that's when we're going to think about a line. So if we have a positive number in front of an x to the first, so think about, I'll write down here, something like 3x, x to the first, right? A positive number in front means it's got a positive slope. So odd degree functions have the same end behavior as a line. And this line has a positive slope, our rise over run, right? So we can use that little quick sketchy sketch to help us remember how the end behavior goes. As x approaches negative infinity. So as x goes to the left, my y goes down. As x approaches negative infinity, y approaches negative infinity. And then my right arrow, as x approaches positive infinity, my y approaches positive infinity. And then our last possible option for us at this time in our lives is to have a negative leading coefficient. Same kind of vibe. We think about a line, but this time with a negative slope, which is going to look something like that. So if we have a negative leading coefficient, it's like a line with a negative slope. It's going to have the same arrows. It may have wiggles and squiggles in between, but it's going to have the same arrows. Okay, they'll pop it in the system. Okay, so our last possible option at this point in our lives is for a negative leading coefficient. And we can write that out as x approaches negative infinity, y approaches, not my haunted house, but positive infinity. And then as x approaches positive infinity, my y's are getting real, real small. Y approaches negative infinity. And that's meant to be a semicolon, not a J. Tradition is to put a semicolon or a comma there. I don't really care what punctuation we put in between. If we get the x approaching and the y approaching, the punctuation's just grammar. And we are going to practice with this a bunch today. So you want to have this written down. This is what we're doing today. We're going to practice using these and identifying it. And right now, these are our 4 options. It's almost like multiple choice. It's one of these 4. These are the only choices we have at this time. I'm not saying these are the only choices that exist, but these are the only ones we're going to see this semester. Okay? So we have lots of things here. But there's really only 4 combinations. It's either going to be a happy face parabola, sad face parabola, or a line. Odd functions go to the disco. Is what I think. Odd ducks go to the disco. Okay. You guys have it written down? Because we're going to practice with this, identifying some end behavior. So these are our first 2 that we already found our leading coefficient and our degree for. It's the same ones, but we're going to find our end behavior. So just to remind ourselves, when we have our ax to the n, we did degree as green, and our leading coefficient is purple. Just trying to keep color coding consistent. So our degree was what on this one? 2. And our leading coefficient, I'm just going to put LC. What was our leading coefficient here? 3. So my degree, is it even or odd? Even. 2 is an even number. My leading coefficient, is it positive or negative? It is positive. So we're going to look at our list for even and positive. So even and positive, that's when we think about a happy face parabola. And this is going to be our end behavior. As x approaches, bless you, negative infinity, y approaches positive infinity. And as x approaches positive infinity, y approaches positive infinity. Questions on that first one? Because that's all we're putting on here is we're just finding our end behavior. So we're going to do the same thing for the other one we had here. We're going to find our degree, and we're going to find our leading coefficient. So what was our degree on this one on the right? 3. And what's my leading coefficient? Negative 1/4. So my degree, is it even or odd? Odd. My leading coefficient, is it positive or negative? Negative. So if it's odd and negative, that's when we think about a line with a negative slope. And it's going to have the same arrows as a line with a negative slope. All this tells us about is the arrows. It doesn't tell us anything about the middle. If it wiggles, squiggles, hops, jumps, skips, whatever. All this tells me is our arrows. So the way we write these arrows again is as x approaches negative infinity, y approaches negative infinity. Nope, sorry, it's approaching positive infinity. That's one of those be super careful things because it's really easy to get our signs switched up. That is why I always give myself this little sketchy sketch, because it's easier to look at that and go, all right, my left arrow is going up. And I went, oops. So left arrow up. As x approaches positive infinity, my y approaches negative infinity. Here's where I get my down arrow. Questions on these two? Yes, dear.
Why isn't it
For this one?
No.
For this one? Because my degree is odd, that means it's going to have opposite arrows. Odd functions always have opposite arrows. Yes, dear. This one? This one? That's just saying my left arrow. We're always going to talk about x to the left and x to the right. Every single time. This part will not change. It's always going to be x to the negative infinity, x to positive infinity. These are the two pieces that change. And it doesn't matter what order you put them in. You can put the positive infinity on the top and negative infinity on the bottom. It doesn't matter. I just tend to follow the same pattern, so it's easier for us to remember. We're going to try this again. We're going to practice with this a little bit more, because it's weird to wrap our brain around, and it's been several months since we did it last. So, right, x to the n. What is my degree here? 4. Our degree is 4. Is that even or odd? Even. 4 is an even number. Our leading coefficient is going to be what here? 2. So is that positive or negative? Positive. So if it's even and positive, my quick thought is a smiley face. Our even positive is a happy face parabola. So the way we write that out all mathily is we say as x approaches negative infinity, what does my y approach? Positive infinity. My left arrow goes up, is what that sentence says. My left arrow is up. So as x approaches positive infinity, what does my y approach? Positive infinity. Because my right arrow is also going up. We don't have any details about what happens between those two arrows. I don't know if we have x-intercepts, if we don't have x-intercepts, what our y-intercept is, where things go, hop, skip, jump, whatever. I have no details about the middle. All I know is where the arrows are. So then we're going to look at this last one over here. What is my degree? 7. Is it even or odd? It's odd. It's all good. It's why I just held it for a second and just let us think. It's okay. It's only 7:45. Like, it's early for mathing. People who take first period math are very, very brave. All right, so our leading coefficient, what's our leading coefficient here? -8. Is that positive or negative? It's negative. We even said it when we say the number. -8 is negative. And I'm lazy, so I tend to write just NEG. So if it's odd and negative, I'm going to think about a line with a negative slope. So we're going to have as x approaches negative infinity, my y approaches what? Positive. So my left arrow is going up. So as x approaches positive infinity, what's happening to my y? It's going to negative infinity. Yes, dear. More specific. So these two pieces are always the same. X approaches negative infinity, X approaches positive infinity. Because I want to know about my left arrow and my right arrow. That's all those say, is left arrow, right arrow. And we're just saying which direction it points. It's going to point up or it's going to point down. Yes, dear, I'm going to let you pass. Okay. We're going to have one more that we do. And we're going to try and get a sketch because it's an x squared. So we've worked with that before. So we're going to see what we remember about giving us a quick sketch of an x squared. So we're not going to do like a true graph. I know I have a whole grid up here, but you can just do like a sketchy sketch. And this is our last one for the day. Oh, come on, screen. Stop being a jerk. There you go. All right, so we've got for water to flow through a garden hose at a certain rate, it needs to have a specific pressure. Through testing, the company produces garden hoses determine the water pressure is by this function. So when we're coming to our sketch or our graph, the story part doesn't really matter. We're just given a function. So we're going to graph the function and state the domain and range. We have an x squared here, which means we can make ourselves a little t-table where we pick values of x to find our y. Since we don't have any numbers added on the end, we're going to take that good view of the center, like the parent function that we always started with. We're going to have our 0, 1, and 2, -1, and -2. And we're just going to substitute them into the function rule. Like, we don't have to do this by hand. We're going to take the equation that is 3/2 and substitute in our -2. And we're going to do that on the calculator. So if we have 3/2 times -2, that's meant to be a 2, -2 squared, we're going to get 6. So when x is -2, and I'll change this so I can do a sketch with you instead of having a proper graph. So the way I would do this on your paper without a graph. I didn't get a chance to make graphs or get the boxes out or anything like that. So the way I would draw this for you, like as you guys, I would give myself a little grid. And I know when x is -2, my y is 6. So let's substitute in -1, same thing. The fraction of 3/2 times -1 squared. And that gives us 3/2. If we want that as a decimal, we get 1.5. So this one is 1.5. So at -1, we're at 1.5. And I can just label stuff. We're going to try and estimate where they are scale-wise, but we're not being super specific. What happens when we substitute in 0? We get 0. Because there's nothing added or subtracted on the end. 3/2 times 0 is 0. What do we get when we substitute in 1? $1.5. And what do we get when we substitute in 2? 6. So we have just graphed our first polynomial function of the chapter. And it's just a parabola. Now, we've worked with a bunch before. So when in doubt, when you're graphing, substitute things into your equation and go from there. What is our domain? I haven't talked about this in a hot minute. We're going to do our domain and range, and this will be it for today. Yes, dear. Yes, from negative infinity to positive infinity. You are exactly right. Because I can pick any x in the entire existence of the universe to substitute into my graph. So negative infinity to positive infinity. And I know I'm way on the edge over here, so it's a little smushed. How about my range? My y values, what happens to them? They're all positive, so how do we say that? So from 0 to infinity, that is exactly how we would write that in our interval notation. Our other ways of saying this, we could say that it's all real numbers, and we could say y has to be greater than 0. That's another way to say they're all positive. I have a tendency to write it this way, but this is also fine, okay? So I'll leave this up for a hot second, but that's where we're going to end today. I am going to pass out the first homework of this chapter. This is 4-1, and you can do the entirety of the front side. The back side is what we're going to talk about tomorrow. You can actually maybe do it if we remember, but it's okay if we don't. Okay, so I'm going to pass these out. And you guys are going to have the rest of the time where you can start working on these. So this is the first homework of the chapter. I'm going to give next one. All right, so the quiz from last week is on Skyward. Bless you. So the scores are in and updated and all that jazz. Our next chapter test is the Thursday before Thanksgiving, I believe. Should be on the 16th. I believe this one actually says 17th. This says the Friday. So I'm going to switch this to be the 16th. Ooh, that's way too fancy. So the 16th, the Thursday before Thanksgiving break. We are also going to have a skills check on Friday of this week. So just like a real short on the computer, like Alex-based skills check. All right, well, you guys have the rest of this time to start working on this.